We are Indian Navy veterans, and much like sailors who sail on open seas and find their way, we are designing axial flux motors to power electrical vehicles and be a part of the EV revolution in the country. As most of you are aware, motors are widely used in virtually every aspect of our lives, from our homes to our factories to our industries. The motors presently in use serve a purpose, but we believe that they are not the most optimum and efficient designs. Thus, our foray in these uncharted waters. The founder of the company is Commander Ramesh Lakra, an avid technocrat whose passion is low frequency electromagnetic analysis. He has worked extensively on a number of assignments, including every aspect of batteries during his naval career. While being associated with batteries, he furthers his expertise in machine design. He has served on board the warships Ganga, Dunagiri, and Vindhyagiri and held various other positions in different organizations in the Indian Navy. I, on my part, have also had the opportunity to work in widely dispersed organizations during my time in the Indian Navy, which have both honed my technical as well as management skills. I have had the opportunity of serving on board the aircraft carrier Virat, the frigates Gomti and Taragiri, and the Coast Guard ship Samudra Prahari. There comes a time in everyone's lives when you want to do something different to challenge yourself. That moment came for us after serving in the Indian Navy for 2 decades, and we started our entrepreneurial journey last year. Being Navy men, weight and volume have always been critical for us, as these are imperatives that play a huge role in every aspect on ships and submarines. It is always packing that all important punch in the smallest package that matters. Electric vehicles were gaining momentum, and we decided to indigenously design and develop powertrains. This was and still is a field where a lot of technology is imported, and we felt that we could contribute to designing powertrains within the country, and thus Contion Powertrain was born. It would be interesting for you to know that electrical vehicles were one of the earliest powered vehicles, but owing to various reasons, fossil fuel based vehicles found favor. The journey of electrical vehicle architecture has gone through various stages and now stands at the cusp of being powered by the wheel. As you all must be aware that an internal combustion engine is one of the most complex pieces of engineering and needs transmission lines and gearboxes to transfer the torque to the wheels to the motor, the vehicle. This very architecture is being now challenged by what is increasingly being known as skateboard configuration, where the four wheels power the vehicles. We therefore are designing axial flux motors so that we can make the wheel the power source of electric vehicle. Going forward, I will try to give a brief insight into what exactly is axial flux and how is it different and better than radial flux machines. As you can see here, in radial flux motors, the flux lines are in radial direction. That is, they emerge from the stator and travel along the radial line towards the rotor. Meanwhile, in the axial flux motor on the right side, the flux lines are along the axis or in the axial direction. This slide will probably help in better understanding the difference between the two types of motors. On the left, you can see a radial flux motor. These types of motors we have all come across in our day-to-day lives. The magnetic lines of force is indicated for better understanding. On the right side is axial flux motor, which, if you notice, is much flatter as compared to the radial flux motor and is often known as a pancake motor. If you take two motors of the same diameter, you can clearly see that the surface area available for flux interaction is much higher in axial flux motors. Thus, these motors have much higher power to weight ratio. The kind of weight and volume reduction that axial flux topology can provide is best illustrated by this comparison. You can see that the axial flux motor, despite being one-third the weight, is able to provide the torque and power equivalent to a radial flux motor, which is much, much heavier. So what is different that makes axial flux motor such an attractive proposition? Some of the key factors are highlighted. And on the right of the screen, you can see we have tried to illustrate a yoke structure of an axial flux stator compared to a radial flux stator. The typical requirements of a motor for powering an electrical vehicle are highlighted on this slide. So you not only need high torque right from the start, but also an efficient functioning over its entire band of operation, which remains the key. This is no easy challenge by any stretch of imagination, and we are trying to find a best fit solution. Some of the different types of motor which are used include the induction motor, which many of you would be familiar who are doing electrical engineering. You would have heard about the permanent magnet motors, which somewhat look like this in structure. And of course, the much lesser heard synchronous reluctance motor. If you have noticed, all the pictorial representations are of radial flux motors, and we as a company want to make that and be in a position to design and manufacture axial flux motors within the country. Electrical vehicles provide an opportunity to disrupt the existing architecture and truly take the power to wheels. Just imagine what better way than to have a vehicle which has a battery and wheels that power it. There would be such a huge reduction of moving parts, which would make the powertrains much more efficient and also reduce maintenance and upkeep issues. For the sake of representation, we have indicated a conventional hybrid powertrain and what we propose with our solutions of hub motors. So what does it actually mean? If you power the vehicle through powered wheels, these are some of the advantages which are self-explanatory, and you can clearly see that they are very different from how these are implemented in presently available IC engine as well as radial flux motor powered vehicles. Some of the companies which hit the big league recently all are working on getting the power to the wheel, and we believe our work in designing axial flux motors will truly herald in a new whole paradigm in powertrains. So where we stand, as we speak, we are prototyping a set of motors which I will briefly tell in the succeeding paragraphs. We are right now prototyping a 10-inch diameter BLDC motor, which you can see can power up to 8 kilowatt power, which is good enough to power a premium segment two-wheeler. Two or four of these motors can go ahead and power a small L3, L5 equivalent loader. We are also prototyping a permanent magnet synchronous motor, which is of 19-inch diameter, and two of these motors would be able to power a small 30-seater bus. We are working on a radial flux design of a switched reluctance motor, which, as you see, does not have magnets. So that means it is as rugged as an induction motor, yet it is able to provide you the initial starting torque, which is required to power a vehicle when they are used as a hub motor configuration. These motors are finding favor all over the world, and a lot of work is happening in the field of switch reluctance motor because these are more efficient and they can be much more rugged as compared to induction motors. We are also working on a design for a radial flux induction motor to be used on a L5 equivalent platform. These are the platforms which are very widely used by the e-commerce platforms for delivery purposes. This was a bird's eye view of the work that we as a company are doing. In the next 2 to 3 months, all the motors that I showcased would be heading their way onto the bench for bench trials. And I'm sure you have a lot of questions. I am afraid this was not a face-to-face interaction where your Q's and A's we could have taken up online. Please feel free to drop in a mail, and rest assured we will get back to you and definitely try to tickle the bones so that people can get into machine design and join our ranks. Thank you so much. Have a lovely day.